Alright guys, here we go, 4-4 video, graphing a function rule. After this lesson I will be able to graph equations that represent functions. Here we go. Again, make sure you stop. Please make sure your volume is on. You need to listen as well as watch. There's lots of little things that we say during the video. Understand. The set of all solutions of an equation forms the equation's graph. A graph may include solutions that do not appear in a table. A real-world graph should only show points that make sense in the given situation. We'll look at that here as we go through 4-4. All right, here we go. First thing we got to be able to do is graph a rule. So they gave us a rule, y equals negative 2x plus 1, and I need to graph it. So the easiest thing to do is to make a table. So if we make a table, we're just going to start picking any number we want, and we're going to plug it in for x and figure out what the y is. And then that'll give us a series of points. So I'm just going to pick any number I want for x. It doesn't matter what you pick. And then I'll figure out what the y number is when I plug it in, and then I'll have a bunch of points. So if I pick negative 1 for x, and I just plug in negative 1 right here for the x, I would wind up with negative 2 times negative 1, which is 2, plus 1 would make 3. So there's a point at negative 1, comma, 3, x, comma, y. If I take 0 and I plug it in, well then I would have negative 2 times 0, which is 0, plus 1 more makes 1. So if I plug in 0, I get 1 for y, so there's a point at 0, 1. If I plug in 1, I would have negative 2 times 1, which would be negative 2, plus 1 more, which would make negative 1, so 1, negative 1. And then if I plug in 2, I would have negative 2 times 2, which would be negative 4, plus 1, which would make negative 3. So the last point would be at 2, comma, negative 3. Alright, so that went pretty quick, so if you need to rewind or pause to get all that down, make sure you do that. Alright, now, once I have that table, all I have to do is plot those points onto the graph. So just graph the ordered pairs. So whenever I graph, I remember my x-axis goes side to side, and my y-axis goes up and down. So I have all these points. First number side to side, second number up and down. Negative 1, 3 would be right there. Left 1, up 3. Start at 0, 0, negative 1, 3. 0, 1. Start at 0, 0, over 0, up 1. There's his point. Start at 0, 0 always. Over 1, down 1. And then start at 0, 0, over 2, down 3. There's that point right there. Okay? So if you notice all those points line up, that is a linear function. So the graph, we might as well draw the line, and it would look like that. Okay, please make sure you draw that line. All right, so now we get into graphing. We got to start doing things a little neater than normal, some of us. All right, here's another equation. So I got y equals x squared plus 1. Again, in order to graph, make a table. So I'm just going to pick some numbers. I'm going to plug them in for x. You can pick any numbers you want. These are just the numbers that I picked. So you can pick any number you want for x. So if I pick negative 1 and I plug it in, I have negative 1 squared plus 1. Well, negative 1 squared is negative 1 times negative 1, which would be 1, plus 1 would make 2. So my point would be negative 1, comma, 2. If I take 0 and I plug it in, I would wind up with 0 squared plus 1. Well, 0 squared is 0, plus 1 would be 1. 0, 1. If I take 1 and plug it in, I'd have 1 squared, which is 1, plus 1 is 2. So 1, comma, 2. And if I take 2 and plug it in, I get 2 squared, which is 4, plus 1 more makes 5, 2, comma, 5. So I have a table. I can make this table as big as I want. I can have as many points as I want. All right, for now we'll say, how about 4? Okay, so when we go to plot those points, we just make our grid. Remember, first number side to side, second number up and down. Negative 1, 2, there he is. 0, 1, there he is. 1, 2, there he is. And 2, 5, there he is. And what you can see is that if you were to continue with more points, you would have another point here. You have another point way up here and way up here. Okay, so the graph would look like that. As a hint, any x squareds are always going to be these u-looking graphs. It's called a parabola. Any x to the first power, like in the first example, will always be a line. Okay? Great. So, when I graph a real-world function rule, choose appropriate intervals for the units on the axes. Okay, so I got to watch out when I make my graph when I'm dealing with real world values. Every interval in the axis should represent the same change in value. So when I go to number my axes, I can't count by 2 and then count by 6 and then count by 1. All right, so it's always going to go the same. If all of the data are non-negative, so 0 or positive, then I would show only the first quadrant of the graph, which is the top right corner of the graph, which if you look at a graph would just be this spot where the x's and the y's are both positive. Okay? So here we go. So as the function rule, W equals blah, 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 146C plus 30,000 represents the total weight, W, in pounds of a concrete mixer truck that carries C cubic feet of concrete. Wow, that's a lot. So this is the weight based on how many feet, how much concrete I'm carrying. If the capacity of the truck is about 200 cubic feet, what is a reasonable graph for the function rule? All right, so I can have any kind of number I want in the C. It says the capacity of the truck is about 200 feet. So I'm just going to pick some numbers for that C number. Now, let's pick some that makes sense because I have a real situation here. So how do I choose values for a real-world independent variable? I look at the information about what the values can be. The independent variable, C in this problem, the capacity of the truck, is limited that it can only be up to 200. All right, so it doesn't make any sense to pick numbers above 200. It also doesn't really make sense to pick small numbers like 1 and 2 and 3. All right, because that would just have my graph all scrunched in there. So I'm going to pick some numbers into my table that would make sense going up to 200. So the truck can hold 0 to 200 cubic feet of concrete. So the only C numbers I want are going up to 200. But again, I don't want to pick 1 and 2, so I'm going to kind of space it out to get to that 200. So I picked 50, I picked 100, I picked 150, I picked 200. And then all I did is I took those numbers and I plugged them in for C. And I saw what I would get. So if I took 0 and plugged it in, 146 times 0 plus 30,000 is 30,000. So 0, comma 30,000. Same thing happens if you plug 50 in. 146 times 50 plus 30,000 is 37.3. If I take 100 and plug it in, etc. 150 plug it in, 200 plug it in. Okay, so I can plug in any points I want, but again, I don't want to go above 200, and I don't want to have all of my numbers scrunched together. So try to spread it out to make your graph make sense. Okay, so now when we go to graph this thing, make sure you've labeled the concrete here. Make sure you've labeled the total weight, because the weight depends on the amount of concrete. All right, so I just plotted those points. Again, as I graph them, my axes are spread out a little bit. All right, so obviously I'm not going to count by ones if I'm trying to go all the way up to 200 in my table. But each of these spaces has to count for the same. So this counts for 25, 50, 75, 100. All right, so even though they're not all labeled there. And then I just plot my points up there. So 50, comma 37.3, well, 50, comma 37.3 would be approximately right there. 100, comma 44.6 would be right there, etc., etc. All right, there's a couple more notes on here. W reaches almost 60,000 pounds, so the W values from 0 to 60,000. All right, makes sense. And I knew that because as I got this bigger, I got close to 60,000. You know? So as I just kind of spread those out to make my graph make sense. All right? Great. Notice there's no arrow on the end of the graph because 200 is the highest I can get. So that's the stopping point right there. All right, so there's a lot of little notes there. Please make sure you take a second and read them. Wouldn't be a bad idea to jot them down. All right, here we go. There's two kinds of graphs. A continuous graph is a graph that is unbroken, so I could put my pencil on it and just keep going, and I can continue with it. Or there's a discrete graph, which is composed of isolated points or isolated dots. Okay? Now, how do I know which one to use? Well, if my independent variable, my x's, can be counted, I would use a discrete graph, like number of cars, number of dogs, number of eggs, things that are whole numbers. I would do a discrete graph. I can't have 2.3 cars or 1.6 eggs. All right, so those have to be whole numbers, so those would be dots. Continuous graph is things that can be measured, time, ounces, right? You could have parts of time. You could have days, minutes, seconds, nanoseconds, okay? And that can be chopped up into small pieces. Distance, you could have feet, inches, half inches, right? So those things can be measured, so those would be continuous graphs. All right, so here we go. Here's a nice example. This is my boy here. He's a local cheese maker. He's making cheddar cheese to sell at the farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown below. Write a function for each situation. Graph each function. Is the graph continuous or discrete? All right, so it's really two different problems. So we'll get to this line here in a second. 1 gallon of milk makes 16 ounces of cheddar cheese. Okay, so they told me that. So in words, the weight W of cheese in ounces depends on the number of gallons of milk used. All right, the more milk I use, the more cheese I can make. All right, so my equation, W equals 16M. All right, the weight equals 16 times the amount of milk. Okay, so as I look here at my table, I made a table and I'm changing the number of gallons of milk. So 1 gallon makes 16 ounces of cheese. 2 gallons, 32 ounces of cheese. 3 gallons, 48 ounces of cheese, etc. So you can pick any numbers you want here and figure out the corresponding values for the amount of cheese. Okay, so as I look at the graph here, what I would see is, as I plot these points, make sure you have the axes labeled and the numbers on them too. So what I see here is I had to go, I'm going from 0 to 4, so I just counted by ones down here. And then here I was getting up to 64, so I counted up this way and spaced it out evenly so that I reached 64. Okay? So it looks something like that. All right, now notice, the points on the graph, well, if I want to know is it continuous or discrete, decide what values are reasonable for the independent variable. For example, even if 3 makes sense and 4 makes sense, fractions and decimals may not. Well, in this case, I'm dealing with my M, which is milk, as my independent variable. Well, I can have a half gallon of milk. I could have a quarter of a gallon of milk, right? So those things are measured. The amount of milk is measured. So those can be in pieces. So that would be a continuous graph. That's why I drew that line in there to connect the points. Any amount of milk makes sense, so I connect the points. The graph is continuous. All right, last one. Each wheel of cheddar cheese costs $9, so the amount A of money made from selling cheese depends on the number of wheels sold. So I'm going to make all these wheels of cheese, and then I'm going to sell them. All right, so I get the amount of money that I get is 9 times the number of wheels of cheese that I sell. I sell each one for $9. The amount is 9 times the number of wheels. Okay, so I made a table. And I just said, okay, well, if I don't sell any wheels, then I make $0. If I sell 1 wheel, I make $9. 2 wheels, $18, etc., etc. I can pick any numbers I want. Okay? So as I graph those things, 0, 0, 1, 9, 2, 18, 3, 27, 4, 36, it looks like that. Okay, so I just plotted those points. Again, please make sure you have the axes labeled with the numbers and the words. Remember, I can tell that if a graph is continuous or discrete by deciding what values are reasonable for the independent variable. So if I look at number of wheels of cheese sold, well, I can't really sell half a wheel of cheese. Okay? So these are whole numbers. These are counted. I sold 1 wheel, or I sold 2 wheels, or I sold 10 wheels. So those are counted. So this is a discrete graph because I'm not going to sell fractions or decimals of the independent variable. That's how I knew to not connect the points. So in the past, you may have always connected the points, but you just have to be a little heads up and look at your independent variable. If it can be counted, then it'll be a discrete graph. If it's measured, then it'll be a continuous graph. Okay? So that's about it for FOFO. I will see you next time, my friends. Peace.